Good afternoon. It is Sunday afternoon, and I just saw a post on the forum about question 18, and I spent some time with students at the end of the week last week going over this question, and there's a lot of little details. So I'm just going to go over this right now. It is thought that about 47% of Australians think unemployment would increase. Assume in a recent poll, 175 out of 400 said they thought unemployment would increase. Estimate the proportion of all Australians today who believe unemployment would increase using a 94% confidence interval. Okay, so I'm going to go over first some of the little details in here and what the symbols are. And before I get into the specific problems, just kind of talk about piece by piece. So this isn't really going to apply to this problem, but they are saying there's some suggestion that in the past, there's been knowledge that 47% of Australians think unemployment would increase. And it's a bizarre statement. It would work for hypothesis tests, which is in topic 7. But for this, it doesn't really apply. But it is worth saying that the idea that you know the number of all Australians' opinion, that would be a population proportion, right? They either think it would increase or they don't think it would increase. So really the success failure would be a certain number think the unemployment will increase and a certain number think something else. Either it won't or it won't change or it'll decrease. So it's really just think it'll increase or don't think it'll increase. So that's a categorical variable and uses proportions. So in this number right here, we have 175 out of 400. So first of all, that 175 would be the number of successes. That many people thought it would increase. And since we're looking at the number that think it will increase, that would be the number of successes. And then divide that by 400, which is the sample size, or n, and it would give you the population, the sample proportion. So out of the sample of 400. Also, just, you see this NP and N times 1 minus P, or sometimes it's NP hat, N times 1 minus P hat. You don't always have to do that calculation. In this case, you're told there are 175 successes, and you could just figure out that for failures, that would be, all the rest would be failures. So that means there would be 225. There are 225 failures in this sample. So just out of the gate, before we get into specific problems, we already know that this meets normality criteria, which basically says you need to have at least 10 successes, at least 10 failures. We have way more than that of both of those, so we're good. So I'm going to clear this out. And let's look at the specific thing. The parameter for this, we're working with proportions. So the parameter is a number about the population. That would be the letter P. With no hat. And what's the wording of the parameter in the context of the problem? So when you look at this list, you're looking for the one that talks about all Australians. You're not talking about 400 Australians because that's the sample. We want to know the proportion of all Australians that think unemployment would increase. So let's find that in this list, the percentage or proportion, and this would be the one, the percentage of all Australians today that believe unemployment would increase. So in this case, we said this is categorical or qualitative information. So because of that, we do need to check that n is greater than or equal to 20n. In other words, the population is more than 20 times the size of the sample. So since it's all Australians and we have 400 in our sample, 20 times 400 is 8,000, and there are definitely more than 8,000 Australians. So we're good. This would not apply. This is a normality criteria for quantitative variables. This would apply. And we actually know that it is 175, so we're good. And we know that this is 225, so we're good. And they bring that 47%, but because we're creating a confidence interval, that assumes we don't know the population proportion. So we could not use NP or N times 1 minus P. And sigma is known or sigma is unknown. That relates to quantitative variables. So there we are. Those are the three. And the assumptions, we already know that NP is 175, which is greater than or equal to 10. So we're good on those, 175 greater than or equal to 10. And we know that this is going to be 225, which is greater than or equal to 10 as well. And we also know that n, capital N, this is interesting. We don't know. They don't say what capital N is. Let's see what it gives us. Oh, if no n is given in the problem, use 1,000,000. So we're assuming there's at least 1,000,000. If you're like me, you would have missed that. It actually followed. And what matters is that's greater than 8,000, and that is 20 times the sample size. The conditions are met to use a 1 proportion z interval. So it's a proportion because it's quantitative. It's not 2 proportions. It's just we're not comparing 2 proportions. In fact, we don't actually get to this in this class. We're not using a t-interval. So that's for means when you don't know the standard deviation, and so on. All right, so it's definitely going to be the 1 proportion z-interval. The symbol and value for the point estimate. Point estimate means the best guess we have is our sample. So that in this case, the sample is in terms of a p hat. And then that number is going to be 175 divided by 400, which I didn't do in advance. 175 divided by 400 is 0.43. Oh, it says leave it as a fraction. Easy enough. That's going to be 175 out of 400. Okay. Oh, and it's going to reduce it, but I think it'll let me not reduce it just to confirm everything's good. So the interval estimate. So this is the interval estimate basically means the confidence interval, lower bound to upper bound. So we're going to need StatCrunch for this, especially because it's a 94% confidence interval. So we don't have any critical values for that. So this is going to take a second just to log in. Sign in. Open it up. And what I'm going to do is go to the normal calculator. I'm going to plug in my mean, which, I'm sorry, I'm not going to a normal calculator. I am going to stat, z-stats, 1 sample with summary. Sorry, last try. Stat, proportion stats, 1 sample with summary. Number of successes, 175. Number of observations, 400. I'm going to click this confidence interval for 94. And let's get what we get. And so these are the numbers we want, the lower limit. So really what that says is based on that sample, for that given sample size, we know it might not be 43.75%, but we know we're pretty confident, 94% confident that the population proportion is a value that's between 39.1% and 48.4%. So let's look back and see how they want us to answer that. The interval estimate for mu. By the way, this question is, sorry, not mu, p. So what this means is the purpose of the interval is to make an approximation for the population proportion, or take a guess at or where we think the population proportion is. So that term, the interval estimate for p, it's kind of like this interval is to make a prediction of what p is, and they want it to 3 decimal places. So that is 0.391, 0.484. 0.391, 0.484. Let's just double check. Yep, we're good. So the conclusion, we are 94% confident, because it's a 94% confident interval, that the percentage of Australians that believe unemployment would increase, that's the description of what P is between 39.1 and 48.4%. All right, let's see how we did. Oh no, it got me. Oh, I didn't answer this first one. That's what the problem. It is P. P is the correct symbol. Everything else was correct. Right. All right. I'm going to make another one of these for quantitative variables as well.